Earthquakes are one of the most frequent natural phenomena on our planet, with about 500,000 being detected each year. Now, unless you live in Japan, that number might scare you, but most of them are so weak that you can barely feel them. Chances are that some of you might actually have an earthquake occurring right below you as you're watching this video, but most likely you wouldn't feel it, or at least I hope. Well, if you're feeling something like an earthquake right now, I'm not sure if you should continue watching this video. Some earthquakes can be really devastating though, like the Shaanxi earthquake in China, which was the deadliest ever, killing around 830,000 people, and the Valdivia earthquake in Chile, which had a magnitude of 9.5, making it the strongest earthquake that was ever recorded. Now, this raises an interesting question. Is an earthquake with a higher magnitude than the one recorded in Chile possible, or is there a theoretical upper limit on the size of an earthquake? How powerful can an earthquake possibly get? But before finding that out, let's quickly understand what exactly happens in an earthquake and how we measure it. The Earth's topmost layer, the crust, isn't just a single piece but is rather divided into a number of tectonic plates that kind of float over the mantle. These plates can either move away or towards each other, or can rub against each other, and each of this action can cause stress to build up over time. Eventually, this stress has to go somewhere, right? So the tectonic plates quickly release the stress in the form of energy along the fault lines in what we see as an earthquake. There are various scales to measure the magnitude of an earthquake, but the ones commonly used are the Richter scale and the moment magnitude scale. The Richter scale is something that most of us have heard of. It's always used in the media to describe how bad an earthquake was. And the way it works is that you have these numbers starting from 1, and an increase of just one number on this scale would mean that the earthquake gets 10 times stronger. And by stronger, I mean it shakes a lot more intensely. So it's not your normal scale. Richter scale is a logarithmic scale. So let's say you have two earthquakes of magnitudes 1 and 2. A magnitude 2 earthquake would be 10 times stronger than a magnitude 1, and a magnitude 3 earthquake would be 10 times stronger than a magnitude 2, which means that it would be 100 times stronger than magnitude 1. And because of such nature of the scale, things get crazy very quickly. A magnitude 3 earthquake can barely be felt, while a magnitude 9 earthquake would mean total destruction. But the Richter scale is no longer used by seismologists since they have found a better scale called the moment magnitude scale. And this also means that whatever the media reports as the Richter scale is most likely the moment magnitude scale, but I guess they're just too lazy to bother about the name. Unlike the Richter scale, which measures how strong the shaking was, the moment magnitude scale measures how much energy was released during an earthquake. And here, increase in one magnitude means 32 times more energy. Remember, the increment was 10 times in Richter scale, but here it's 32 times. So a magnitude 3 earthquake would release 1024 times more energy compared to a magnitude 1 earthquake. So now that we have a good idea of the magnitude scales, let's get back to the actual topic of this video, because I think I've digressed a bit. So the most powerful earthquake ever recorded, the Valdivia earthquake in Chile, was 9.5 on the moment magnitude scale. And to give you an idea about it, this earthquake triggered huge tsunamis which killed 138 people in Japan. Yes, you heard that right. The tsunami traveled as far as Japan from Chile and killed people there. Not just Japan, but also to the Philippines and New Zealand. That's literally halfway around the world. So what would it take for an earthquake to be even stronger than this? The magnitude of an earthquake is related to the length of the fault on which it occurs. A fault basically means the gap between the tectonic plates. The longer the fault length, the bigger the earthquake. Let's say that the San Andreas Fault in California, which is 1,300 kilometers long and 16 kilometers deep, completely ruptures. That would only be enough to create an earthquake of magnitude 8.47, a good 10 times weaker than the Chilean earthquake. But on the other hand, if the entire 3,000 kilometer stretch of faults from Japan Trench to the Kuril-Kamchatsky Trench ruptured together and shifted by 60 meters, it's enough to cause an earthquake of magnitude 10. And if this kind of earthquake occurs, it could trigger tsunamis that could last for days. However, this estimation made by scientists at the Hoku University in Japan seems to be disputed. According to the United States Geological Survey, a fault length of 14,000 kilometers would be required to produce a magnitude 10 earthquake, instead of just 3,000 as predicted by scientists in Japan. And to produce a magnitude 10.5 earthquake, a fault length of 80,000 kilometers would be needed. The circumference of Earth itself is 40,000 kilometers, and you can't have a fault line that's longer than the circumference of the Earth. So a 10.5 magnitude earthquake is very unlikely. In fact, if we combine the energy released in all earthquakes that have taken place in last 100 years, it still wouldn't be equal to 10.5 on moment magnitude scale. So the limitation on size of an earthquake arises from the circumference of Earth itself. Now, it's a bit relieving that you may never experience a magnitude 10.5 earthquake in your lifetime, but at the same time you might be a bit underwhelmed by this answer. You might have expected some kind of a mind-blowing figure that would split the Earth into two. Not that we want it to happen, but we are not done yet. We haven't explored another possibility. When the dinosaur-killing asteroid struck the Earth 65 million years ago, it created a seismic shock of magnitude 13. But the effects of that were felt not just at the site of impact. Almost every other place on Earth experienced a magnitude 9 earthquake at the same time. That is because an earthquake greater than magnitude 12 at any one location on Earth would release so much energy that it would feel like a magnitude 9 earthquake everywhere else on the planet. So, though the faults on Earth themselves may not produce an earthquake over magnitude 10, but impacts from celestial objects like asteroids can certainly do, even surpassing the magnitude 13 mark, which is 1,000,000 times more powerful than the Valdivia earthquake in Chile. But what if you go a few more magnitudes higher? Hypothetically speaking, let's say magnitude 18. What would that look like? A magnitude 18 earthquake would cause the Earth to explode into pieces. That's because such an earthquake would release so much energy that it would exceed something called the gravitational binding energy of our planet. For those of you who are not familiar with this term, in oversimplified words, it simply means the energy required to separate all the matter on Earth. So if the scale hits 18, the energy released would overcome the gravitational binding energy, and that's enough to blow the Earth into bits. So now there's no more Earth. So I guess that's the theoretical upper limit. Or is it? Quakes don't just happen on Earth, they happen on other celestial bodies as well. There's moonquakes, Marsquakes, Venusquakes, Sunquakes, and so on. What you see on your screen right now is an actual footage of an 11.3 magnitude Sunquake. And if you want to break the sun into pieces by any chance, a magnitude 24 Sunquake would be sufficient. So now there's no more sun. But what if we want to experience a quake of even higher magnitudes? For that, we need to go quite far, about 50,000 light years far. This is SGR 180620, a magnetar on the far side of the Milky Way. A magnetar is basically a neutron star with an extremely powerful magnetic field, about a quadrillion times as powerful as Earth's. And this magnetar was the site of an extremely powerful Starquake, which, when converted to earthquake magnitude, would result in a magnitude 32 earthquake, which is approximately a decillion times more powerful than the most powerful earthquake ever recorded on Earth. Decillion, that is a 1 followed by 33 zeros, and that is just mind-blowingly ridiculous. I mean, you can't comprehend such a thing. And this isn't some hypothetical scenario. This Starquake actually took place 50,000 light years away, thankfully, because if it had happened closer, let's say 10 light years away, then the energy released from it would have severely damaged the ozone layer and caused mass extinction. So surely that must be the upper limit. But wait, what if we take a step further? What if a quake releases as much energy as the entire mass energy of the observable universe? What would its magnitude be? So this is the equation that is used for calculating the energy released. In place of E, I'm going to put the value of mass energy of the universe, which is 4.20 into 10 to the power of 69 joules. Wait a second, is this real? Oh, it is. Anyway, so if we plug in this value in this equation, we get the value of m, that is magnitude, and the answer is around 43.066. And I guess that's it. A magnitude 43 quake is what it takes to break the scale, because that would release an astonishing amount of energy, equivalent to the entire mass energy of our universe. Just don't ever try imagining that.